Today I will discuss a lecture on complex number. Complex number is basically represented as c is equal to x plus iota y, and we can represent this complex number into polar form, and its polar form is given as c is equal to r into cos theta plus iota sin theta, where r is the magnitude and theta is the direction from x-axis. So if we graphically represent this complex number, then we can represent it as if we draw x and y axis, and here is a point P whose coordinates are x and y, and it is at distance r from the origin. So we can resolve this into components x and y, and if we apply triangular laws, then cos theta is equal to base over hypotenuse, and here base is x and hypotenuse is y. So x is equal to cos theta is equal to x over y, x over r, and if we find the value of x, then we get x is equal to r cos theta. Similarly, we can represent sin theta is equal to perpendicular over hypotenuse, and here perpendicular is y and hypotenuse is r. So y is equal to r sin theta. So we represent complex number into polar form as x plus iota y, and here we put values of x and y, x r cos theta and y r sin theta. So r cos theta plus r iota sin theta. So here r is the common in both values, so we take it as common. So r into cos theta plus iota sin theta. So this is the polar form of any complex number. So know why we represent any complex number into polar form. It has some importance. Polar form is used because it turns complicated algebra into simple geometry, and it is used in the electrical engineering and signal processing, physics, and in physics we deal with the waves and oscillations where magnitude and phase angle are involved. So this polar form of complex number is used in the physics. Other than this, division becomes easy, where we divide the magnitude and subtract the angles only. Otherwise, in rectangular form, division becomes more complicated. Similarly, we can also do multiplication, and multiplication becomes easy, where we multiply the magnitudes and add the angles. Suppose we have two numbers z1 is equal to r1 cos theta 1 plus sin theta 1. Similarly, the other complex number is z2, where z2 is equal to r2 cos theta 2 plus iota sin theta 2. So if we multiply them, then we will get their multiplication as r1 into r2 big brackets into cos theta plus cos theta 1 plus cos theta 2 plus iota sin theta 1 plus sin theta 2. Whereas in rectangular form, multiplication become messy. So we try to understand this polar form from the following example, and example is that express the following number in polar form. The number is minus under root 3 plus iota. So its solution, let we consider this complex number as z. So z is equal to minus under root 3 plus iota, as polar form of the complex number is z is equal to r into cos theta plus iota sin theta. So we will get r is equal to under root minus 3 plus 1 under root 3 minus 3 का square plus 1 का square. So r is equal to 3 plus 1 and this is equal to under root 4. So we will get r is equal to 2. So theta is equal to 1 by under root 3 and tan theta is equal to 1 by under root 3 and theta is equal to tan inverse 1 by under root 3. So we will get theta is equal to pi by 6. But if we see the quadrant, then here x is negative and y is positive. So generally we know that in the first quadrant value of x is positive and value of y is also positive. In the second quadrant value of x is negative and value of y is positive, and in third quadrant both x and y become negative, and in the fourth quadrant x become positive, y become negative. So if we see the complex number in the complex number x is negative and y is positive, so it means our complex number is lying in the second quadrant. And if we take its argument or angle, then this is our general notations for the arguments. So and then a complex number is lying in the second quadrant, so its argument would be rc is equal to pi minus theta. So pi is equal to pi minus 6, pi minus pi by 6, and this would become 5 pi by 6. So our complex number would be in the polar form as. So this is our answer. Thank you.